friends, you can see this is an induction coil and it's working perfectly. We have wireless transmission of electric energy. You can see, so tune in and see how you can develop such a circuit. I'll guide you step by step, and please remember to subscribe to my YouTube channel. I'm looking for subscribers, so kindly be one of them. So let's dive into practical. In this tutorial, I'm going to show you how to light LED wirelessly through induction. I've seen most people are trying to do the same, but you realize that when you try to follow their circuit and attempt to do it, it fails. So this is 100% proven to be working, and I'm going to show you step by step, and I hope you enjoy. So I'll first start by introducing my components, the components that I'm going to use for this project. So here is a prototyping board. So this prototyping board is where we'll solder the components, and this is 1 kilo ohm resistor, so you'll see it in the circuit. Here is 47 microfarads capacitor. Here is an E555 timer. This is 2N222 transistor. This is a green LED that we'll use on the transmitter side. This is 8 pin IC socket. These are 2 pins terminal blocks. This here is 1 kilo ohm potentiometer. This is the red LED that will be used on the receiver side. This one here is 1000 microfarads capacitor. Next we have 10 kilo ohm resistor. So in my circuit you'll see that I've used 33 kilo ohms. So replace that with this 10 kilo ohm resistor. So don't use 33 kilo ohm in your circuit. This here is 9 volts battery clip, and here we have 9 volts battery. So this will be the source of power on the transmitter side. The other component that we should not forget is the enameled copper wire. So you can see here is my enameled copper wire. So it is from this enameled copper wire that will make our coil. So you can see this enameled copper wire is 0.315 millimeters in diameter. And from the circuit, you saw that the number of turns that we'll be doing are 30 turns of the copper wire. So these 30 turns will maintain a diameter of about 5 centimeter. So let's have a diameter of 5 centimeters for the coil with the 30 turns. In this circuit, you can see the receiver side and the transmitter side. So you can see both transmitter and receiver do have 30 turns. of the enameled copper. Yeah, so and the transmitter circuit side, we have these 30 turns halved, so that junction has got 15 on the other side and 15 turns on the other side. But the transmitter, but the receiver circuit, with the receiver circuit, you can see that we have pure 30 turns, so there's no splitting, after which we connect the LED. Yeah, so let's get started by making the turns. We'll start with the receiver side, then solder the LED. So I'll use this to make the turns, so 30 of them. So here we have 30 turns. So here are my 30 turns. Let me tape them. Yeah, so this is the circuit for our receiver. Let's make the transmitter side. So with the transmitter side, we'll do 15 turns, then split it and continue. So let's start. Yeah, so here we have 15 turns. Let's split it. So this one here, we will solder. Let's use this to split. So we are using heat to remove the enameled part. So this one will let us solder. So let's continue and have 15 more. Yeah, so here we have 15 more turns. So a total of 30 turns. We can now cut it here. We are now taping it. The next thing is to burn the ends. Yeah, so let's burn the ends to remove the enamel so that our copper can conduct. So remember to solder the junction. Remember to solder it. So we'll so this is the junction in the transmitter. Don't forget to solder it. Next is to solder the LED, the receiver LED. Yeah, now this one looks good. Yeah, so our receiver is complete. Next is the transmitter. So you can see the transmitter circuit. So I'll solder this on the prototyping board. Yeah. After doing that, I'll share it. Then we connect the transmitter coil on the PCB. So in your circuit, just make the similar on the board. Yeah, so this 33 kilo ohms resistor will use 10 kilo ohms in place of it. So remember to do that. Otherwise, the rest of the parts will remain as it is. Yeah, so this one here is a potentiometer. You can now see the circuit is complete. Now what remains is to solder the transmitter coil. Yeah, so this is a complete circuit. I would like us to test and see how the onboard LED on the transmitter will work. Yeah, so you can see how it's working. Yeah, so this is how it's working, and I can use the potentiometer here to adjust the rate of blinking. So you can see how the rate is changing. If I want it to rotate faster, I can do this. Yeah, so you can have a look at it. This is our circuit. Yeah. So here is the potentiometer, and here we have another resistor. So this resistor here is, this one here is 10 kilo ohms. Yeah, so you can use any value and see how the blinking rate is affected. Yeah, so that's about the circuit. The next thing now is to connect this coil, this one here, to the circuit. So you can see that the junction to the coil is connected to the output pin of the NE 555 timer through 1 kilo ohm resistor. Then one end of the coil is connected to the base of the transistor 2N222A through 10k ohm resistor with 1,000 microfarads capacitor. Then the other end of the coil is connected to the collector of the transistor. That's what I'm going to do right now. Yes, so if you take a look at the circuit, this is how it is. Yeah, you can now see the circuit is complete. I've just soldered the coil that I made. So this is our transmitter circuit and this is our receiver circuit. So I'll power it on. Let me power it on. Yeah, so you can see the LED on the transmitter side is blinking. We expect the LED on the receiver side to blink with the same frequency. So let's place it. Yeah, you can now see. You can see it. You can see. So the induction is happening and both the LEDs are blinking. So if I increase the distance, you can see what happens. So what is happening, let's place this here and drop this on top and see. Yeah, still it's working. Yeah, so that's the circuit. I would like to adjust our potentiometer. So the blinking rate, I don't know why it's behaving that way. Let me remove that and place it direct. Why is it missing? Yeah, that's perfect now. So you can see the blinking rate is the same for them, so the frequency is the same. Let's see. Let's introduce obstacle and see if it's affected. So it's missing a time. Yeah, so if you increase the distance, you can see how the field is affected. Let's adjust the rate and see if we increase the distance, if it will still be affected. Yeah, so that's it. Thank you. And if you don't mind, please subscribe to my YouTube channel. I'm looking for subscribers. I've got very low number of subscribers, so please add up to the number. I'll really appreciate. Thank you, and let's meet in another tutorial.